Hello, the Australian Space Biology Symposium. My name is Kieran Blair. It's a real pleasure to be presenting to you today among this great list of speakers. As you know, the world has changed recently, and over the last 9 months, as much as we'd love to be in person with each other and talking in depth about some of the subjects that are coming up today, we have to be virtual. However, what a symposium we have, what a list of speakers. Firstly, a big thank you to the ASBS organising team for inviting us and putting this all together. It's amazing what we're going to hear today, and I'm really excited to listen to everybody else's presentations as well. Thank you for pulling it all together. So I'm here today to talk to you about being systems and the parabolic flight capability we're setting up in Australia. Let's get started. So I'm going to spend 10 to 15 minutes today talking to you about what we're doing and how we can hopefully help you out with the research and development that's going on in the space industry at the moment. Today, I'm going to run through a typical mission profile of a parabolic flight and the requirements for investigators, and that'll hopefully answer some of the big questions you have. If anything, I'd very much like to pique your interest about the potential projects in your respective fields and hopefully where we can help with the grants process and create opportunities for collaboration in Australia and internationally as well. What is a parabolic flight? A parabolic flight is the use of an aircraft to cancel out the effects of gravity by flying parabolas. So these periods of gravity usually last from 20 to 30 seconds. And depending on the mission profile and the design, we can do somewhere between 20 to 40 periods of this alternate gravity per flight. So why are we doing this now? It's access. We are trying to open up the opportunities for Australia to participate in this new space industry that's starting. I've got a background in flight testing and evaluation, and I always found the more realistic we created our environments, the better results we got. So it's a big impetus for us starting up this capability and integrating into the new space industry coming up. So in the new space industry as well, this ability to test in real environments is a real risk mitigator for technology projects, for example. Once you send it up there, it doesn't usually come down in one piece. So you want to know it's performing to spec before you get it up there. These are the things we're trying to help with. Now, for experimenters, we're talking about biology today. As you imagine, there are a few requirements that we need completed by the investigators before we can go flying. I'm going to run through these. So firstly, there are limitations with our aircraft, and we need to design our mission profiles around those limitations. So the aircraft can create gravities anywhere between 0 to 1.5 G. So we can cater for lunar, Martian, or space projects. The amount of these that are required needs to be known by the provincial or incorporated into the principal investigators' plan for how they're going to conduct their experimentation. Secondly, aircraft limitations also include aviation regulatory environment limitations, and these can be factored into experimental designs as well. What I'm talking about here is there are requirements around things like explosives, cryo, liquids, and the size and weight of experiments that can be carried both by the aircraft and from the regulatory perspective. These need to be incorporated into your planning. As a rough guide, if your experiment's under about 1 meter cubed, you're in the right area. Any bigger or heavier is not so much a problem, it's just that these things will need to be assembled on the aircraft, so keep that in mind. What I've shown you here is an experimentation and some designs for testing racks that are used on the Canadian's parabolic aircraft. Very similar, a little bit smaller aircraft than ours, but this is how we're going to integrate them into the aircraft just for your information. Requirements from a medical point of view are also quite important. Your crew needs to be fit and healthy, and we're going to make sure this is checked before flight. Our safety, as much as it's a cliche, really is the first priority. All these requirements need to be adhered to. However, they can be planned for in the planning process of your experimentation. So don't expect any of these things to take you by surprise. We're going to provide you with all the information you need before you go flying. what we're actually planning for. Here's the timeline we're usually looking at running. From about T60, we're expecting all the hardware and the design of the experimentation to be complete. And then it's just a rundown in days, as you can see, until we reach the exact date we're going to go flying, where we start arriving, setting up our experiments, doing the safety checks, and then it's pretty much Qantas 101. So we do our pre-flight briefs, safety briefs, jump on board, do the experimentation, come home, unload them, and then celebrate for tea and medals. So that's the generic flow of a day that you can expect for a parabolic flight that we're going to provide. This is the aircraft we're going to be flying in. It's called a Challenger CL604. It's one of the biggest small jets in the world. No, really. We've chosen this aircraft because it is known for its world-class reliability, its sturdiness, and that it's got a nice large cabin for lots of testing to be able to be done. Now look, it's not the Airbus A320, #ESA, but it is very fit for purpose. Have a look on the right side of the slide here. You can see the cabin. So the cabin is completely reconfigurable, and there's the size you can expect. So for a small aircraft, it's actually quite large. We'd be looking to divide the cabin up to about 3 sections for small experiments, which will give us a room for about 5 experimenters. Obviously, as the projects get larger, less space is available, less people can come on board. Now, thing that everybody wants to know, right? How much is this going to cost? And like most things, it depends. However, compared to the other available parabolic aircraft around the world, we're quite competitive. In the US, you're looking at around $60,000 just for the flight, not incorporating logistical costs of getting there. My current estimates for us in Australia for a palleted experiment is in the region of $20,000 to $60,000, depending on the experimenter. Obviously, this is subject to change as we're still getting all the details of this sorted, but as a rough guide, I thought it'd be good to give you some information there. Okay, that's the aircraft. They're the generic profile, so hopefully this has answered a few of your specific questions. Let's get talking about what we can actually do for you now. So everyone in the room is going to have more knowledge in their field than I obviously do. So rather than tell you what's actually available and what you can do, I'll talk to the barriers we're removing, and you can make your own determinations, but I'll also provide you some examples of what have been done previously. So to set the scene, this diagram shows NASA's life sciences translational research path. So firstly, what barriers are we removing for this interdependent set of 3 elements? Well, firstly, it's access to space environments. None of this can be done without accessing those environments. So as we touched on previously, this allows more realistic validation of results. But in Australia, the big thing we're solving for is the scope of research available to be done. So obviously this has very obvious benefits for those watching or in the room. Let's use an example for an infectious disease. It's not taken very kindly to take infectious diseases on a small tube aircraft to another country. So those barriers, those logistical barriers, we're getting rid of in Australia to increase that scope of research available. As a more bigger means to think about what the aircraft, the barriers the aircraft is reducing, is to think about it as a bridge between the laboratory and the ISS, which is what it's mostly used for in the ESA. So validating or qualifying experiments for the ISS and more realistic testing. Now, the scope of the testing we can do is quite broad. So I'll show you the next slide, which I've commandeered from the ESA about the actual testing on parabolic aircraft that has been done previously. So on the left is what I imagine most people in the room would be interested in, but let's not forget your cousins in the STEM fields as well. Now, this list is not exhaustive. If we can take something safely flying, we will, and we will do that and figure out how we're going to do that with you in the planning process. Great, so the next part I'd like to quickly touch on is what we're trying to do in the R&D sector with you. So when I first started investigating the viability of flight, I was spurred on after reading about a project in Australia to create a small orbiting laboratory. And from my aerospace background and knowledge, I realized that that was a while off and their timeline for that project was ambitious. So to be able to create any microgravity environments required us to pretty much go back to parabolic flights as it was available and has been shown to be effective. After this, I distilled down where we could actually help. So really what we can help with is the access to facilities or environments that replicate space. Similar to NASA, we want to take technologies and research from ground-based laboratory environments and put them in realistic environments to validate the feasibility. Also, having this in Australia obviously increases the scope we can do, as we've spoken about. As a grants mechanism as well, I thought it'd be very useful to have an ability to conduct some novel experimentation in the fields that Australia has strengths in, such as biology. And then that allows people doing research and development in those fields to obtain a better way to get grants, or a more competitive way to obtain grants. And especially if that's incorporated under frameworks such as the Moon to Mars, it's a real net positive for all involved. Thirdly, the opportunities we can create collaboratively are a net benefit. And we've already seen that just within our basic collaborations within the National Research Council in Canada regarding human spaceflight and physiological studies. So that collaboration is a benefit. Also, the benefit comes from bringing that collaboration to Australia, which we're looking to empower such that you can be more involved with those projects as well. The groundwork of this is being laid down by the Australian Space Agency currently. Looking forward, what do we really see this becoming that is useful for you is an end-to-end testing facility where you can conduct woe-to-go testing on all your experimentation to gain the most reliable results possible. And also an end-to-end testing facility for those interested in spin-offs and commercial pipelines is also a very useful tool to have. So we're very keen to help with that and to enable those pipelines to be created. When are we looking at getting up and running? We're working on it now. We've been working it for a while, but obviously, as you can read, mid to late 2021 is when we're looking like we're going to be flying first. So our intention is to run a few flights and a couple of programs to begin with, just to get the capability up and running. And we'd really appreciate your involvement with that, such with solving for your problems and making your experimentation as valid as possible. The team that we're setting this up with, so with my background in aerospace testing evaluation, I've brought on a few of my pals from the Defence Force and the Air Force as the A team for T&E within the Defence Force. We're also working with Dr. Gail Isles, who's a renowned RMIT physicist and has flown more than 500 parabolas training astronauts with the ESA. So we've got a very comprehensive team, and these are the organisations we've already done a little bit of work with about standing this capability up within Australia. So lastly, getting involved. We're solving for all the requirements on the right side of this slide, but to make sure that we can get flying as soon as possible, it's good to have as much support as possible to validate the assumptions or the claims that we're making. There are a lot of barriers to getting this capability up and running, so as much support as possible is going to make it happen faster. So if you see this as a beneficial capability for yourself now, or even in the future, I'd very much appreciate your help with a few of these low overhead things. First and easiest, expressions of interest. I've got a QR code there for you, which will take you to a type form. In a very small amount of time, I can gain a better understanding of what type of testing the industry is looking at doing, and then I can follow up as required. Secondly, please get in contact. We'd love to have as many people involved as possible with letters of support for us supporting your program, which means you're supporting our program as well. So that collaboration is just the next level of confidence and that we can use to get flying, because we want to drive those important research projects and the programs in particular, and that support is just an indication of the validity of what we're standing up here. So Lastly, sorry, is please get in contact about your grant applications, or just include us in your grant applications for the use of microgravity or lunar Martian gravity capabilities. This just demonstrates the capabilities utility within the R&D sector in the current time. And that will help us, all these three things will help us along our path of getting the aircraft stood up as quickly as possible. And that's all I have. So thank you very much. It's a pleasure again to be speaking with you here today. I'm really looking forward to the rest of the speakers as well. So I'll be chiming in and watching many of those presentations. Thank you again to the ASBS team for setting this all up. Here are my contact details. Please get in touch anytime. And very good. See you all. Bye.